In this video, we will be doing yet another exercise to collect and process XML data of the internet. In this exercise, we're going to revisit the World Bank data. The World Bank API provides data in XML or JSON format. Indeed, the default format is XML, so if I don't provide a data format, I'm going to get XML by default. Let's take a look at this URL. If I go to this URL, this basically gives me the population in the US over the time. That's the structure of the XML file. And again, it looks like a tree. There is a root element tag in which there are multiple children tags. They're called data in this case. Each child tag in this case has multiple children tags, including indicator, country, ISO code, date, value, so on and so forth. The question itself is asking us about the year in which the largest growth in population was reported. So the largest growth since the year before. So this basically entails getting the data and processing it in order to answer the question. I'm going to start by importing the needed package. I need to import request, I need to import pandas, and I need to import also element 3. Once I imported these packages, I'm going to go forward and collect the data. To get the data out of the internet, I'm going to use the requests package and use the function get. I know the URL I want to get, which is this one, so I'm going to simply copy and paste it. And I'm going to store the result in the response object here. I'm going to check the status code, which is 200, so it's a success. And then I'm going to get the text of the response. Next, I'm going to create my XML object by calling the function from string from element3 class and passing the text to it. Basically telling me that the XML starts with a tag worldbank.org data, and that's the root tag. Now I want to revisit the XML file here, because in this XML file you can see that the root tag is basically WB data, while here if you take a look at the element tag itself, it doesn't say WB data, it says curly brackets http worldbank.org and then data. And the reason to that is that there is an alias here. The alias here is a shortcut so that the creators of this XML file do not repeat this large number of text characters for each time of these tags. They decided to create an XML alias here and substituting each WB with this whole thing, http www.worldbank.org. So for each one of these tags, it's a substitution of that alias. WB stands for this whole thing. Thus, when we look at our data, which has been parsed by element 3, we don't see WB, we see this whole thing in curly bracket, which is substitution of WB. Next, we need to determine what piece of information we need to get. We know the country name, so we shouldn't be collecting the country name. We only need to collect the year and population. The year itself is under data. Underneath it, we have date, and that's the year. And then the population is the value itself. So what we're going to do now, we're going to use XPATH to write an expression to get all of the data tags, and in each one of these tags we're going to get date and then we're going to get value. What we're going to do, we're going to take this root tag, and we're going to call the function findAll to specify the XPATH expression. Now I want to basically specify all of the sub-data tags in this root tag. This will basically give me all of the tags associated with all of the observations in the XML file. I'm going to use a similar strategy to the one we used in the previous exercise. I'm going to start with an empty list, and I'm going to go for each one of these observations, for each observation or for each tag. Let's call it tag. In these tags, I'm going to get the year. The year itself is the date tag within this tag. Now, because we are in a tag, what we need to do, we need to specify the XML path relative to this tag. And the XML path relative to this tag is the WB dot, right, date, WB colon date, and WB, we know it stands for this alias. So what I'm going to do, I'm going to put, oops, here date. Next, I'm going to get population, which is the value tag in each one of these subtags. So this is going to be the value for each one of these populations here. Let's type it, this thing. Now each one of these is a tag, and I am interested in the text of the tag. So I'm going to convert this one to text, I'm going to convert this one to text, and I'm going to append a dictionary to my result list. And the dictionary will be year is year, and population is population. Once I'm done, I have a list of records indicating the data that we had before. My next step is then to convert this data to a pandas data frame so I can process it. What I'm going to do, I'm going to create the data frame from this result list, and this is the data frame under question. Let's do some data transformations here. I'm going to convert year to be an integer, and I'm going to call the function to numeric to convert population to a number while preserving the null values. So what I'm going to do, I'm going to convert year to be year by applying int, and I'm going to take the population and pass it to the function pd.toNumeric. This function is a universal function, hence I can pass in a series to this function and it will keep the null values. And then df population is going to be df population converted to a number. Next, I'm going to set index to be year. I only care about population in this question, so it makes sense to convert the data frame to a series. I'm going to set index to be year, and then take population as a single column to convert to grab it as a series. Once I have so, I have the data here. It probably also makes sense to start from an early year rather from a later year, because it's something that changes over time. So I'm going to sort on the index. Once I'm done, I'm going to call this one series or data. That's basically the series of data that I want to use to answer the question. The question is asking us to compare each year with the year before to calculate the growth. So let's define growth as the difference in between 1 year and the year before divided over the year before. For example, the growth in 1961 was basically this value in 1961 minus the previous value in 1960. Those are how many people were born in that year, and then dividing it over the value of the baseline, which is the year before. We can multiply it by 100 to make it like a percentage. That's basically 1.6% growth in between years 60 and 61. And we need to repeat this process, this calculation, over all of the values. There are different ways to do it. I'm going to implement this manually and then introduce a function in pandas that allow us to do this operation. So what I'm going to do here, I'm going to start by creating another series. Let's call this one S2, and I'm going to start with a copy of S. Note that I don't want to S2 being the same as S, because I want to read S and along the line change the values in S2. Next, what I'm going to do, I'm going to go over each index value in S or S2, doesn't make a difference, they're the same right now, in the index. Obviously I is the year, so if I print I, those are going to be the year. So perhaps it makes sense to call it year rather than I in this case for each year in s.index. Next, what I'm going to do, I'm going to peek at the year before. So previous year is going to be year -1. Now for the first value here, we need an exception because we don't have an observation for year 1959. So what I'm going to do is to check again if previous year is in the index itself. If that's the case, then we can go ahead and get our calculation conducted here. So if that's the case, I'm going to do S2 at the value of year is equal to S at the value of year minus S at the value of previous year, previous year, divided over the value of S in the previous year. Once I calculate this, you can see that I calculated the differences, and of course I can multiply by 100 here, and the values are calculated here, except that I've got a problem here. For the first year, 1960, the value is completely incorrect because I don't have 1952. So I'm going to add an else statement here to say that if previous year is not an index, which is the first observation, I'm going to set S2 year to be none or not a number. That's basically to say that, well, this one is, I don't know, because I don't know 1959, so the growth in 1960 is not known in this case. Same thing for the year here, the last observation, 2019, because 2019 itself was not known anyhow, so it remains as not a number in this case. Okay, so those are the growth rates. Next, we need to calculate or locate the year in which the largest growth was reported. It's an exercise of sorting these in a descending order. And we can see that 1961 and 1962 observed the largest growth since the years before them. This operation that we have coded in here is called shifting. We're basically shifting the series to calculate a series that has the same index but has values shifted by 1. Indeed, this is an operation supported by pandas. If I take a look at S, that's the value of S, my series S. If I do shift S, it's going to shift the values, one by one. So the value of 1961 will be the value of 1960. Obviously 1960 will not have a value, it will have an NA because there is no value before it. That's the operation called shifting. So what I can do instead of doing this manually is to basically shift, because shift is basically giving me the results of looking at the future. So I can do S minus S dot shift. That's the previous year. Then divided again over S dot shift. And I can multiply by 100. That basically will give me the same results. So what I can do here in this case, I can assign this to S3, and I can do S3 dot sort values sending is false. That will give me essentially the same results.